Hello everybody and welcome back to the Code Wrinkles channel for a brand new video. This time we'll talk once again about Blazor and about a new feature that we have in Blazor on .NET 5 that I find very useful, and this is Blazor Component Virtualization. And I just want to set a little bit of context before we really get going. The idea is that when we work on single page application, but on web application in general, sooner rather than later, we'll be in a scenario where we will have to display a lot of data, usually using data grids. Of course, in web apps we call them usually tables or things like that. But the idea is that at some points, for instance, we might need to render and to show data or grids that contain, let's say, maybe 5,000 rows. And of course, if we want to render that entire table at one time or in one single go, then of course we will have some performance issues. And this is right where this component virtualization kicks in, because using this feature we can actually render only the parts of the data or a subset of the data that we actually really want to display, and not all 5,000 rows at a time. Using a different example, if we have a data set with 5,000 rows, using component virtualization, what we can do is, for instance, that we have that we actually render only 10 rows, because this is, for instance, is just an example, but this is actually the amount of rows that actually fit into our screen, for instance, or into our div. And when we scroll, then the additional data gets loaded. And this is actually how this idea of component virtualization works. And in order to show this, we have created a standard Blazor template, but we have used the hosted with ASP.NET Core backend API. And this is what we have on the screen right now, really the standard template that we have in Blazor hosted with the ASP.NET Core. There are only two things that I did to this template to just not waste time during this video. And this one, or the first one, was that in a www root folder of this Blazor WebAssembly app, I have added a CSV file which is called salesdata.csv. And one thing that I will do is, let me move the camera at the side a little bit. We have to go here, of course, to properties, and here I just want to copy this file. Actually, always copy. Let's set it to always copy. And yeah, that should actually do it. Control S, and that should do it. Let's move the camera right now back where it was previously, because we don't really need it right now. And the other thing is that in this, let me make the WebAssembly app smaller. And the other thing is that I have installed a NuGet package which is called the CSV parser, because we will read a CSV file. And we will use the CSV parser for that. We have here a small warning because the CSV parser is an older package, and we cannot restore it with .NET 5. But the idea is that it would actually work with what we need so far. So let's get started right now, and we'll start in our API project. And here I will just add another controller. I usually like to add the controllers as classes. And let's call this sales data controller. Hopefully I have typed it correctly, and it seems to be okay. So we'll have a very simple controller. So first of all, we have to inherit from controller, of course. Then we'll need to add using ASP.NET Core MVC. And let's also specify the route, of course, here at this controller using the route attribute. And of course, in the route, we want to use the controller name. So we'll have, controller. So that should be it. And here we'll have a very simple method. It would be a public, it would be async, because we want to read the file. So we will do this asynchronously. So it would be async. It will return a task of iActionResult, of course. And let's call it get sales data. We don't need any incoming parameters. Then what we'll do first, we will have to read the file as bytes. So we'll have var file bytes, and this would be equals to await system IO, now the file, and here we have read all read all lines async, sorry, read all bytes async. This is actually what we need. And of course we need to specify here where we actually want to look. And if we look at our folder structure, we are here right now in this Blazor Virtualization Server, and the file is located in the virtualization client. So we'll have actually to go up one level, and here that should be the client, and then we'll have www root folder, and we'll have then sales.-data.csv, and this should be our CSV file, so it should be okay, I guess. Then of course we want to read the contents of this byte array, contents, and this would be for this we'll use system.text, of course, encoding, default, and here we'll have the get string. It gets actually or reads a byte array as a string, and we'll have to provide the file bytes. So that should be okay. And then we can get the raw data, and this would be, here we'll use the CSV parser, new CSV parser, and here we'll have to specify the delimiter, and that should be the comma, of course. And then we'll have a parse, and we'll parse the contents, and then we want to return an array of that. So the idea here is actually very simple, but of course in a real application we will have, or we would have here, some strongly typed classes or objects. So we would create actually a class that would represent a sales data row, but for simplicity's sake I didn't do this here. So what we will return instead is actually the entire table, so it would be a 2D array or a matrix. So this is what we will return from here. So then we just have here to return okay, and then we'll return the raw data, and actually that should do it for the controller. So if we think about our server part, about our backend API, we are all set right now. So let's make this small here, and let's enlarge this Blazor Virtualization client project that contains our Blazor WebAssembly app. And here we will have to set up a few things. First of all, I would like to go to the nav menu and add on the left navigation menu that we have on the sidebar in the standard template another item, and I'll just copy the last one, and I will, let's have this under sales, and it would be here not fetch data, but it would be here sales data. So we will have on the left actually right now a navigation menu, or a navigation item, a nav link actually, that would redirect us or route us to our component that we will actually create right away. And we'll do this under pages, where we have also this fetch data component. This is where we will create our component right now. So let's go here on pages, right click, and we'll add a razor component, and we'll call this simple sales. So that's it. And let's make a little bit of space here, because we will need, first of all, we will have to provide here this page directive, because this would be a routable component, and this would be under sales. So that should actually be okay. And we'll need the HTTP client here. So inject HTTP client, and let's call this HTTP here. We'll need this actually later. And that's, I guess, everything that we will need right now. So for the title, let's change this to sales data, and we'll have some very basic here setup to do. First of all, let's create a div. This template uses Bootstrap, so let's add a Bootstrap class here. Class equals call, and the let's have it 8. Okay. And if you hear an ambulance, I'm really sorry for that. Unfortunately, I'm here right at the main street, and even if my mic has a lot of noise cancellation, there are some noises that I really can't take out. So of course, then we can proceed with that, and here we can just start to add our table. So this is what we want to add, and using the same CSS that we have already in this Blazor template application, let's use the class table that is also used on the fetch data component, and that would actually style our component exactly the same way. And then we will have the t body, or the body of the table. And here is actually where our Blazor virtualization component will actually kick in, because here is where we would usually take a data context, or the data that we want to render, and we will do a for each, and for each record or for each entry in that data context, we would actually create a table row with the specified table data. And here is where we don't want actually to do this the old way, but we want to use this new component virtualization feature. And that's actually very easy to do, because what we have to do is actually only use a built-in component that was already created for that. And that component is called virtualize. So if we just use virtualize, that would actually create this Blazor virtualization for us. Of course, we still need to specify some information. Like for instance, we want to specify items, and for that we will have to set up a data collection, and we'll do this just a little bit later. For now, of course, it has a red squiggly line because we can't find this name here right now, but we'll look into this just a little bit later. And then the other important things that we need to provide is a context that would actually specify a single item in that data set. And let's call this, for instance, entry. Of course, you can call it whatever you want, sales report. It's important because this using this context, or the variable that you define in this context, you will be able, as we will see just in a few seconds, to display different parts of that specific object as different table cells. And then what we need to do here is to also use a very briefly if. As said, from the API, what we return is not some strongly typed collection, but we just return a two-dimensional string array. So in this case, in the result or in the data set, actually, we actually go to each array or to each string array in that main data collection, and we want to make sure that it is really a certain, or that it is really a string array. So if entry is of type array, and let's also give it a name that should be row. So if this happens, then what we can do is, well, we will add a table row for each of these string arrays. And in this table row, we have a for each, and for each var cell, because it is, we identify a cell actually in that CSV file in a row. In this case, we just want to display the table data. So it would be td, and we'll have it cell, and that should do it. And if, for instance, we don't have an array here, we'll also think about that, and in that case we just provide an else. And in this else, what we'll do actually is simply create a new table row and table data, and we'll specify actually here the row, or the entry, sorry. Because if it is not array, we just want to specify or to print that entry right there. And actually, that is all for our markup. What we need to do, of course, right now is to think a little bit about what we need to create here in the code part, because we just need to get this data, of course. And of course, we'll get this data from our API. As said, that would be a string array, so private string array. Let's call it data. So yeah, right now we have this data, so the red squiggly line should go away, and it really did. Then the other thing that I want to do here is override the on initialized async method protected, override async task on initialized async. And here in this method, what we want to do is, of course, we want to get data. So data would be equal to await. We will use the HTTP that we injected, and we'll get here get from a JSON async. And of course, what we can specify here is that we want to bind the result that we get actually to a 2D string array. And of course, we just also need to specify where we want to make the call. And we just want to make the call here right now to how did we call this sales data. And hopefully I don't have any errors here. So HTTP, let's delete that one. So right now it should be fine. So we will make the call to sales data. It will return us a 2D array. We'll actually have that 2D array in data, and then we can theoretically use this virtualized component to actually render our data, but as said, in a virtualized way. So let's actually run this application, because actually we should be set up with everything that we need. So let's just run the application and see if everything adds up. It just takes a little bit until everything is built correctly, and until the browser is launched, which happens actually right now. Let's make this actually larger. And what we want to do once the application is loaded, I would also like to open the developer tools, because there's something that we would actually look into and to see exactly how, or that this virtualization actually works. So let's undock this right now, because I want to have this separately. Okay, let's also go to this network tab and let's move to this sales data. And we see that we actually got all this information here. So we get all this information. And in order to show you this idea of virtualization, let's just right click here and go on inspect. And this would actually go and send us actually to this specific table row. And we see here that we have some table rows. I guess there are 10 or 12 or something like that, but there are not 5002. So if we start to scroll here, just look a little bit, things change here, because we get additional data while scrolling. So we render the data while we scroll down. But that's actually very, very cool, because we didn't need to create the entire table with 5000 rows at a time, but we can just virtualize and display the data and add the necessary rows while we scroll down, or of course while we scroll up. It's exactly the same thing that happens. You see, things change. And this is actually how component virtualization works in Blazor WebAssembly. But of course, you can use this component virtualization also with Blazor Server. So it would work exactly the same. There is no difference about it. So that's actually fairly cool, I would say. But I just don't want to wrap up yet, because we have to think about one very important aspect when we develop a real application. And when we need to actually provide or create this type of tables with a lot of data, we actually will never really get all the data at the same time. So one very important thing here about this virtualization component is that we can actually specify a delegate that would actually fetch the data when it is needed from a data service, for instance. And let's try to see how we can implement that. So first of all, what we need to change here is, in this case, we don't use this data field actually as the data set, as the source for our table, but we use this items provider. And the items provider, I say that I want to be load sales data. Of course, we don't have a method that is called load sales data yet, but we will create it right now. So this method can even be private. This would also be async, and it would return a value task of it will actually return a value task of items provider result. Let's first implement this, and then I will try to explain exactly what happens. And what we have here is that we will provide actually this items result of type of string array, because each element that we will want to render is actually a string array. And let's call it load sales data. And when this delegate actually gets called by this virtualization component, what happens is that it also passes in an items provider request. So let's have this here, items provider request, and let's call it request. Good. Now we will not send calls each time that we want to render something, but instead we'll go for a different tactic here. We'll load all the data actually when we first actually display this component, but we actually, or we can say that we can cache this data, and once the component needs more data, we feed only portions of that cached data that the component actually needs, and we'll see how this actually works. So let's get this started. For this, we will want to add a few more things here. First of all, we will need, and we'll see just in a second also why, an int that would represent the total items or total entries, let's say, because we have data entries or sales entries, total entries, and we'll set this actually to 0 at the beginning. And then we'll have here also a private bool, and here let's say it's first request, and we'll set this to true, and we'll see exactly why we will or why we want to have it like that. And then we can go here in our method and do the following. So if, let's have an if, so if first request, so if it is the very first request, then in that case what we actually want to do is that we actually want to get the data that we need and set it actually to that data that we already have here. So let's actually try to do this right now. Good. So what we will do here is that var, or we can just say that data equals wait HTTP get from JSON async. So it's exactly the same thing that we did previously, and here gets from JSON async, and what we want, or what we'll get from JSON is a string to the array, and we'll have to make actually the call exactly to the same endpoint, so it would be sales data. Okay, so this is actually the first thing that we want to do, and we still have here this problem that the HTTP doesn't get recognized. But if we, I don't know, let's try to rebuild it. This happens sometimes in Visual Studio, unfortunately. But even if we did that, it's exactly the same thing. So it doesn't find HTTP. Let's just close this this Razor component and let's open it again. And this time, I guess everything would be okay. Yeah. Okay. Unfortunately, this type of things happen, and I don't know exactly why. But yeah, we'll continue. Of course, we still have an error because we don't return anything right now. Now, what we actually do here is we set the total entries to data.length, And we'll need this information because this the virtualization component actually works with this type of information. And then the first request we set to false, because as said, we get all the data when we run or when we get into this method the first time, and then all the other times we actually already have this data and we want to just take some chunks of the data and feed it to the virtualization component. So what we want to do here is that after we get to this if, so if it is not the first request, then we already have the data and total entries and things like that, so we don't have to get it again. Sorry for that. So in that case, what we can do here is var data to display, and this would be equal, and we'll use some link magic data skip, and we'll start actually with a request start index, and I will, once we finish the code and we'll see it working, I'll go through each step and explain what happens under the hood. So we skip this, and then what we want to do is we want to take and then request dot count, and that's actually how we will actually get a subset of the data that we need to feed to the virtualization component. Now, when we specify a delegate to this virtualization component, what we need to return is actually an items provider result, in our case of type of string array, because we return a result of a collection that actually contains arrays. So we'll return new items provider result of type string array, because each element in our collection is actually a string array. And of course we'll have to also specify in the constructor, we'll have to specify the data that needs to be displayed and the total entries. This is how the items provider result needs to be constructed, and this is why we also need this total entries. So right now we still have some errors here, but I'm not sure if these errors are actually real errors or if they come from the fact that things don't work correctly right now in Visual Studio, or at least in my installation. So let's close this component and reopen it, and in fact we don't have any errors right now. So what we can do here is comment out this on initialized async, even though we could actually also get the data in this on initialized async and then just use this raw data. But I just wanted here to, let's say, try to showcase how we would do this actually if we even wanted to maybe make a call to the API each time that we need to feed new data. And this is a scenario that we could use, for instance, if our API supports paging and things like that. So let's for now comment out this override of on initialized async, and yeah, let's do that. Let's save everything and let's run the application again. So the outcome should actually be exactly the same. So all our table should be virtualized, meaning that we will only display or we will only render the rows that actually fit into our screen at that certain point. And once we scroll, I would expect that we'd actually get more and more data. So let's let's go here on sales data, and we see that yeah, we get here all this type of data. Unfortunately, probably something was not loaded correctly, like a CSS file or things or similar to that. But let's go to inspect here, and we see here this table row, and we'll see actually here this entire list of different table rows that we have here. But if we start to scroll, you see that we add actually more rows actually here to what we display. Of course, once rows go outside of what we can view, they are also deleted. So every time we scroll, actually everything is still kept in sync, based on what actually happens into our virtualization component. And as said, this time we actually just provide the delegate to this virtualization component that actually provides the new data once it is requested. In our case, it is a little bit simpler because we just get the entire data and we actually have it in this data field, and then we just return subsets of the data field based on what happens in this component virtualization. And before we wrap up, just as said, as promised, I just want to go over to what happens here. The idea is that when we provide an items provider, so a delegate, to this virtualized component, we have, of course, to adhere to a certain contract. And the contract says that, okay, if you provide a delegate here, what you need to take into consideration is that that delegate should return a value task of items provider result of the type that you would actually want to render. Here would be, for instance, if you would render employees, would be of type employee. If we would have our sales data classes, that would be an items provider result of sales data. But as said, we didn't want to overcomplicate this. So in our case, this is a very simple string array, because this is what each element of this collection that needs to be rendered actually is, a string array. And in this methods, or when we want to adhere to the contract, also the virtualized component provides us this items provider request. And this items provider request instance actually contains some information about the data that it actually needs in order to render on the UI. And it contains a start index, so actually where we need to start feeding more data, or the index in our data source at which we need to start feeding more data. And then it contains the request count. How many new items does the virtualized component actually need in order to display in our UI? And these are actually two very important pieces of information that we actually need to be aware of. Because actually what happens is that this virtualized component exactly tells us that we need some new data starting at this specific index, and we need exactly 4 new entries or 10 new entries. All the calculations behind of how many entries are really needed are done by the virtualized component, so we don't have to take care about that. We just need to take a look into this information that the virtualized component actually provides us when it actually calls this method, and then use this information in order to create this subset of data that we actually need to feed to this virtualized component in order to render on the UI. And yeah, this is actually how everything works. So just as a short recap, this virtualized component really helps us to render huge amounts of data without the need actually to display all the data at the same time. So we just render the data that fits on the screen, and we just load the additional data that we need once we scroll down or scroll up. And in order to do this, we have 2 different ways. First, or the first option is that we provide actually an items collection. So we provide the entire collection at one point, and then the visualized component does the magic behind it. Or the second approach that would actually probably be mostly used in the production-ready apps that we will develop is to provide a delegate for items provider. And in this delegate, we can actually implement our logic that will get the necessary data that needs to display it from our, for instance, data service. So we just take into consideration, okay, from what index do we need to start? So this is an information that we could even use maybe to identify the page where we want to start, or similar to that. And then we have also the count. How many elements do we need to provide or to feed actually to this virtualized component in that specific moment? And just before we wrap up, a very nice feature, or a very important, or a very nice example where we could actually use this is, for instance, if you want to build a social network, something like Facebook or things like that, or Twitter, or even Instagram. So if you scroll, we have this experience that we usually call as an endless scroll. So your timeline, your newsfeed, you can scroll endlessly and it will actually never get to the end of it. And this is, so if you want to have or to create a social network using Blazor, once again, it's really not important if it's Blazor WebAssembly or Blazor Server. This virtualized component works in both exactly the same way. But the idea is that you just have to provide or to have a data context that contains a lot of newsfeed entries, items, or things like that. And then you can virtualize them and you can create very, very easily this endless scroll experience in your Blazor app using this very, very simple component and using, for instance, these two different options to achieve this that we looked into right here in this video. So thank you very much for watching. If you think that this content might be important for you or for others, don't be shy and hit the thumbs up button, hit the subscribe button if you didn't subscribe already. And if you are really excited about this video, then just feel free to share it with your peers, with your colleagues, on your social networks, and wherever you might see fit. This being said, thank you very much for watching, and until the next time, I wish you the very, very best.